To start off with, I want to let you know that this set of notes is going to be divided up into two sections. This first section, we're going to talk about what is energy, how are energy and work related, and what are the two basic kinds of energy. The other three key questions we'll save for another time. Words to know, though, for all this: energy, work, kinetic energy, potential energy, gravitational potential energy, mechanical energy, sound energy, thermal energy, chemical energy, electrical energy, electromagnetic energy, nuclear energy, energy conversion, and law of conservation of energy. What is the mover of matter? Energy. Energy is what makes stuff happen. It's how we get things done. It's how we light up the cities. It's how we get cars to move. It's how we have our factories make things. Energy is everywhere. It heats our homes. It cooks our food. It runs our electronic gadgets and our TVs. Energy is everywhere. We use it all the time. But what exactly is energy? Well, energy is the ability to do work or cause change. Energy is measured in the units of joules. You might already have guessed that energy and work are related. Now remember, work happens when a force moves an object a distance. And work is the transfer of energy. And work is also measured in units of joules. And whenever work occurs, energy is involved. So, what exactly do we need energy for? Well, let's look at Nathan here and maybe part of his day. It's 8 o'clock in the morning and Nathan is still asleep. Is he using energy? The alarm clock goes off. Nathan wakes up and gets ready for school. Is he using energy? It's time for breakfast. Is he using energy? Nathan is traveling to school by bus. Is he using energy here? Nathan is working hard in school. He's using energy. Nathan is home again, finished his homework, and settled down to watch some television. Is he using energy? So, what exactly do we need energy for? Why is it important? Well, list some different things that you do that use energy. Go ahead and list what energy was used during the different times of day. What are the two basic kinds of energy? Well, energy is classified as either kinetic energy, which is the energy of motion. And this is where energy is transferred. Right? All that is kinetic energy. We think moving things, we think kinetic energy. But we also have potential energy. This is stored energy. This is the ability to make things move and to transfer energy. So this potential energy is stored energy. It's at the ready. It can be used. There's two different kinds of potential energy that we can talk about right now. Elastic potential energy, and this is energy stored by stretching or compressing something like springs, elastic rubber bands. In this case, we're looking at a recurve bow. And right here, there's no stored energy yet. But we pull it back, it starts to store that energy, and we can turn that potential energy into kinetic energy by letting it go, and that arrow flies off with, you guessed it, kinetic energy. There's also gravitational potential energy. Energy stored based on the height of an object from the ground. So the more height and mass an object has, the more gravitational potential energy it has. And as it falls from a height, it builds up more kinetic energy but loses that potential energy. Let's look at some examples of that. So we have a ball at the top of a hill. It has a bunch of potential energy, gravitational potential energy, but no kinetic energy yet because it's not moving. Someone pushes it down the hill. The ball is now rolling down the hill and it has both kinetic and potential energy. So it's moving, it has kinetic energy, but it also has further to go, so it still has some potential energy. Now the ball has reached the bottom of the hill, but it's still rolling. It has kinetic energy, but no potential energy. And a ball at the bottom of the hill, which is not rolling, has neither potential nor kinetic energy. So energy doesn't just stay in one state. It can move, right? We have energy changing one form to another. And this is something we need to get used to thinking about, that energy changes form. In this case, it's going from potential to kinetic. Let's look at another example with a little roller coaster. Here, we have all potential energy. Well, that coaster starts going down. That potential energy is changing the kinetic energy. And now we have even amounts of kinetic, Ke, and potential, Pe energy. Keeps going down, keeps going down. It's all kinetic energy, going really fast, lots of motion. But then it starts going back up this hump in the roller coaster, and we start building more potential energy again because it's going further up. It has more gravitational potential energy. And this is how a roller coaster works. Scientists actually look at this. Engineers look at the energy used and the forces involved in roller coasters to get them to work. They need to make sure they have enough kinetic energy to get up a hill. Now, this is all great, and there's lots of other forms of energy that we're going to look at. First, we need to understand and master the two types of kinetic, the energy of motion, and potential, stored energy.